ever wondered what happens when you type your favorite command into the Linux console? There is a series of steps that happens behind the scenes. Let's understand this with a real-world example. Let's imagine you're at a library and you ask the librarian to show you a list of books available in a specific section. This is quite similar to what happens when you type the ls command in the Linux console to list files and directories. Here's a step-by-step process. The first step is input interpretation. When you type ls and hit enter, it's like you're asking the librarian to show the books. The shell, like the librarian, interprets this as a command. In the second step, called shell processing, the first task is command parsing. The shell breaks down what you typed into the command ls and any options, for example, if you added -l for detailed listing. It's like the librarian understanding that you want a list of books and also specifying that you want detailed information about each book. In the second task of the command parsing, the shell looks for the ls program in a list of directories specified in the path environment variable, similar to the librarian knowing exactly where to find the catalog of books. In Linux, the path variable is an environment variable that specifies a list of directories where the shell looks for executable files. When you type a command in the terminal, the shell searches through these directories in the order they are listed in path to find the corresponding executable file. Also, if ls is set as an alias in your shell configuration, the shell will expand it to its original command, like the librarian recognizing a shorthand or nickname you use for the book list. In Linux, the alias command is used to create shortcuts for frequently used commands or to redefine existing commands. An alias allows you to define a new name for a command or a series of commands, making it easier and faster to execute them. For example, if you often use lsal to list all files in a directory with detailed information, you can create an alias like this. Once the alias is defined, you can use it as a shortcut. This ll command will execute lsll. The third step is creating a process using various system call, in this case fork and exec. Let's first understand what is a system call. A system call is a way for programs to interact with the operating system. It provides an interface between user-level applications and the operating system's kernel. When a program needs to perform a task that requires access to hardware or system resources like reading a file, allocating memory, or communicating with other processes, it makes a system call. Now the question is, why can't a user space program can't make a direct call to hardware, and why it need to rely on system calls? And the answer to that, allowing user space programs to access hardware directly, could lead to security vulnerabilities. Malicious programs could exploit direct access to hardware to compromise the system, steal data, or interfere with other programs. Now back to original question of creating a process. The shell creates a new process for the ls command using a system call such as fork. This is like the librarian asking an assistant to handle your request while they continue helping other people. After that, exec system call replaces the memory space of the fork process with the ls program, transforming it from a duplicate of the shell into the actual ls program. Imagine the assistant now taking on the role of fetching the book list. The fourth step is the execution of the ls command. The ls command interacts with the file system, using system calls like opendir, readdir, and closedir to read the contents of directories. This is like the assistant going to the book section, checking each shelf, and listing the books. The command then sorts the entries usually alphabetically and formats the output based on the options provided or defaults. It's like the assistant organizing the list of books in alphabetical order and presenting it nicely. The fifth step is displaying the output, a list of files and directories, to the standard output, typically your terminal screen. It's like the assistant handing you the organized list of books. Upon completion, the ls command terminates and sends an exit status back to the shell 0 for success, non-zero for failure. The assistant then reports back to the librarian that the task is done. After waiting for ls to finish, the shell regains control and displays the prompt for your next command. The librarian is now ready to assist you with your next request. There are some additional details and special considerations. I have already spoke about system call in third step, but there is still one question: why do we need exec system call when we create the process using fork? Let's understand this in simple language. When you type a command and press enter, the shell uses fork to create a new process. Now you have two processes, the shell parent and the new process child. The shell uses exec in the child process to replace its code with the code for the command you typed. The child process is now running the new command, while the parent process, the shell continues waiting for the next command. So fork is for creating a new process, and exec is for running a new program in that process. Both are needed because often you want to create a new process with fork and then run a different program in it with exec. Also, certain environment variables can modify the behavior of ls, similar to how different library policies or user preferences might affect how the assistant presents the book list. For example, -color option. This environment variable is used to define the colors for different types of files and directories when using ls with the -color option. And finally, some special considerations like permission checks. In the step 4, ls checks the permissions of files and directories it lists. It can only list contents if the user has the appropriate permissions, just like the librarian can only show you books that you're allowed to access. For example, if you log in as normal user and try to list the file owned by root, you will get permission denied error. Also, if you are trying to list symbolic link, ls handles them according to its arguments, either showing the link itself or the file it points to. This is like the assistant showing you either the main book or a reference card that points to it. Simply put, when you type a command like ls in the terminal, your computer goes through a step-by-step process to show you what's in a folder. It starts by understanding what you typed, then finds and runs the ls program, sorts out all the files and folders, and finally shows them to you on the screen. Along the way, it checks if you're allowed to see everything and deals with any shortcuts or special requests you've made. This process showcases how your computer follows your commands quickly and efficiently, ensuring you get precisely what you requested.